Hey guys, this is Coach Lowe, and we're going to talk a little bit about isosceles and equilateral triangles. So this is contextual geometry, Chapter 6, Section 4, isosceles and equilateral triangles. So let's get some theorems out of the way. These need to go in your theorem section. So theorem 6.2, isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So let's draw a little isosceles triangle. So remember, isosceles means that we have two sides that are congruent to each other. So here's an isosceles. Let me make this a little bit longer so it doesn't quite look as equilateral as it does right now. There we go. All right, so two sides of the triangle, there are the legs. This would be the base. This would be the vertex angle. So two sides of an isosceles triangle are congruent, then their opposite angles are also congruent. The angles opposite those sides. So here's the side. That would be the angle opposite, the side that's across from it. Another way to think about it is if you look at this angle, and I trace the sides that make up this angle, let's call it A, this side that's not colored in is the side opposite. Or if you're standing here and you throw a rock out in front of you, it's going to hit that side. So angle A and side BC would go together. Angle B and side AC would go together. So if I'm looking at side AC and it's congruent to CB, then angle B, which is opposite AC, is congruent to angle A, which is opposite CB. All right, theorem 6.3, the median from the vertex angle of an isosceles triangle lies on the perpendicular bisector of the base and the angle bisector of the vertex angle. Okay, so I know you want the English version. I got it. I got you. I got you. All right, so let's draw another example here. So this is an isosceles triangle again, so there are my congruent sides. So here's what it's saying. The median is on the perpendicular bisector of the base. So if I wanted to bisect this base with a perpendicular line, it is the exact same line that I would use to draw draw the median. It's also the exact same line that I would use for the angle bisector. So kind of crazy. They all go together. The median, the perpendicular bisector, and the angle bisector, which means these angles are also equal to each other now, right? And we already know that these angles are equal to each other. We just busted out with some craziness, right? That's awesome. All right, so you can see side, angle, side, angle, side, angle. We have all kinds of stuff going on here. All right, so 6.4, the converse of the isosceles triangle theorem. So the converse of 6.2 here, which means we can go the other direction with it. If two angles are congruent, so if I get these base angles to be congruent, I know it's an isosceles triangle because that means the opposite sides are congruent. The sides opposite these angles are also congruent. All right, and then theorem 6.5. A triangle is equilateral if and only if it's equiangular. So equiangular means that all of these angles are equal to each other, which means how much are they? 80 divided by 3, right? Yeah, 60 degrees, exactly. So equiangular, if you see 60 degrees on one of these and the sides are marked equal or the angles are marked equal, you know that all three of them are 60. So a triangle is equilateral, which means all the sides are equal if and only if it's equiangular. If and only if means it works both directions. It means I can read this definition this way or I could read it this way. A triangle is equiangular if and only if it's equilateral. So my angles are equal, my sides are equal, my sides are equal, my angles are equal. So kind of a cool thing. All right, let's try some of these out. All right, so number one, find the value of x. First, I want to identify what type of triangle I'm dealing with. I'm dealing with an isosceles triangle, and I see these legs are congruent to each other. The angles opposite those legs are congruent, so this angle is congruent to this one, and they've given me some expressions, so I know since those angles are equal, I can set the expressions equal to each other and solve. So I'm going to go ahead and subtract 4x from both sides to get it away from this negative 20. And so that's going to leave me a negative 20. Make sure you take that sign that's in front of the number. It's attached with that 20 for now. 3x minus 4x gives me a negative 1x, and I want to solve for x. I'm going to divide both sides by negative 1, so I see that x is 20. They wanted the value of x, not the value of the angle, but if I had to find it, I would see that it's 60 degrees. Plug in 20 here, I also get 60, which actually makes this an equilateral triangle. Equiangular, equilateral. All right, so that brings me to another point. An isosceles triangle has to have at least two sides that are congruent to each other, which means I could actually classify an equilateral triangle as also an isosceles triangle. All right, so let's look at number 2. By the way, this was the theorem. Let's go back. Theorem 6.2, isosceles triangle theorem. That's how we knew to use this. This is theorem 6.2. This is actually theorem 6.4. This is the converse, because we're going to start with some angles and move to the sides. So I see they've marked these angles are congruent, which means opposite sides, the sides opposite those angles are congruent. Okay, if these guys are congruent to each other, that means they're equal in measure. I can set these expressions equal to each other now and solve. So this time I'm going to take x's to the left and numbers to the right. And you may be like, why did you do that? You didn't do that over here. Well, notice there was a number on this side and not one over here. So I was trying to get the x's isolated to one side the quickest way possible. Not the only way to work this problem. All right, so I'm going to move the number over. It doesn't matter if you move numbers or the variables first. So I have 3x equals x plus 16. I'm going to subtract x. If you want to slide a 1 in front, you can. Subtract 1x from both sides. So 2x equals 16. Last step would be divide by 2. So I see that x is equal to 8. Again, you can plug that in here just to make sure that it checks. These sides should be equal. 3 times 8 is 24. Minus 6 is 18. And 8 plus 10 is 18. So we are good to go. All right, now let's check out this one. This one's a little different. Isosceles triangle again, but notice they gave us the vertex angle. These two angles are equal to each other. All right, so now let's think about that. I know that these two angles and this angle will add to be 180. So I'm going to subtract 28 from 180, and that will tell me what's left over to split between these two base angles. So 152 degrees left over. 152 degrees has to be split with these two angles because they are equal to each other. So we can do 152 divided by 2. 2 goes into 15 7 times with 1 left over, and 2 into 12 6 times. So x is 76 degrees in this case, and that's actually the measure of those base angles. Check would be 76 plus 28 should add to be 180 degrees. All right, let's check out this guy right here. All right, so we see that this angle is 2x. And they want us to solve for x. So I see I have two isosceles triangles. First, I'm going to look at this one because I have a base angle. I know that these two are the bases because these are the legs, and I'm going opposite the legs to get the angles. That means if this angle is 5x, so is that angle. I also know about vertical angles. Check that out. Vertical angles are congruent, so I know that this angle is 2x. So now I have 3 angles in a triangle, and I know they have to add to be exactly 180 degrees. So I have 2x plus 5x, which is 12x, equals 180. And then I'll divide both sides by 12. So 12 goes into 18 one time with 6 left over, and 5 times 12 is 60, so 60 divided by 12 is 5. X equals 15. You can do that with your calculator if you'd like, but shouldn't have a problem doing it that way. All right. Whew. Okay, so let's check this out. Number 5, we have, what is this? This is an equilateral triangle, isn't it? Because this is 60. If I take 180 minus 60, that leaves me 120. Split between 2 makes these guys 60 degrees, which tells me these sides are equal to each other. If this is 6x minus 30, then so is this guy. And then when we move to this triangle over here, I see markings on it that match with this guy. So 4x plus 2 equals 6x minus 30. Now we can solve for x. I'll move my numbers to the right and my variables to the left. So I'm going to move the 2 first. I'll subtract 2 from both sides. So 4x equals 6x minus 32. And subtracting 6x from both sides, and negative 2x equals negative 32. So I want to divide both sides by a negative 2. So x is 3 goes into 2 once with 1 left over, and 2 goes into 12 6 times. So x is 16. 16 times 2 is 32. Whew. Okay, last one, guys. All right, let's set these sides equal to each other. Why would we do that? Well, it's an isosceles triangle. This side is equal to this side. Those are my legs. And so opposite those legs would be the base angles. So 3x plus 10 equals 5x minus 10. We're getting our algebra workout on today, aren't we? Yeah, buddy. All right, subtract 5x from both sides. Negative 2x plus 10 equals negative 10. Subtract 10 from both sides. Negative 2x equals negative 20. X is 10 because we divided both sides by negative 2. Woo whoop! All right, guys, we are done. This will be awesome to work on together in class, and I'll see you guys soon. This is Coach Lowe, and I'm out.